So the previous recorded videos, we did a mass balance. Now, there's been quite a number of iterations of this mass balance, and the results previously show the method, but the results have changed a bit as I've detected problems. And it's really to focus on getting this recording done so I don't have to repeat it online in case something goes wrong. But here we're simply going to focus on the fact that the mass balance also provides an error analysis. And basically, for whatever reason, the flows are really good, but we're looking for values around 1. And we're getting values of 0.4 there. And if we move along, a value there of 0.05, that indicates that there's a strong difference between the experimental and the balanced is much better than what we thought it would be using the experimental SD. So we have a look at the results, and this isn't really functional, the solid flows, but the assays are. And it says the average is 0.429. And we're really looking for a value of 1. And this tells we could even drop it down to 0.06 here. And then we get much tighter standard deviations. And this is the way we calculate the standard deviations. All of these calculations for standard deviations are automated. And the most important thing is the fact that we've specified a level of confidence in each measurement, for which there's the various options, which I think I've discussed before. And it's either here we would really use either standard or unused, or indeed if it's not measured but we want to estimate it, we would use missing. So that's the error analysis, and I'll move on to actually doing a different level of the mass balance. So if we go to MMMass, this error isn't really used at the moment. I've simplified it, but fine, we can do that. We say initialization, and we run it. And then we unload the results. Now, there's really not much difference between the results using the standard deviations, not using the standard deviations, which is what we expect. This indicates the fact that the information theory approach is probably sufficient for most users. Personally, I had to and ah whether I would include this level of using standard deviations, but because it's consistent with the mineral processes currently do mass balance, I decided to introduce it. There are some differences between the way I use standard deviations and convention. I've discussed this in a LinkedIn article about standard deviations, but basically least squares minimization, as is commonly used by most mineral processes in mass balancing, is wrong. That's all there is to it. I just couldn't bring myself to deliberately do something wrong.